Alright guys, we're doing 8.1 today, systems of equations. Not too bad here. Let me give you some definitions, a couple of notes, and then we'll just jump into a few examples. Alright, let's start with the definition. A system of equations in two variables is a collection of two or more equations in x and y. So this is just a standard definition of system of equations. What I want you to pay special attention to is the next two notes. A solution to a system of equations in two variables, so x and y, is an ordered pair, x comma y. This ordered pair satisfies each equation in the system. So in other words, we'll have two, you'll see this in the examples, we'll have two equations in x and y variables. The solution is an ordered pair that solves each of those equations. Now on the graph, a solution x comma y is the intersection of the graphs of the two equations. Okay? So we'll jump into a few examples here, and it'll make these definitions a bit clearer. Alright, so first example. We want to solve the system y equals x squared and y equals 2x plus 3. Now the first method I want you to look at is the substitution method. That method says we're going to solve one of these equations for a variable, which is already done for us, and then work our way backwards from there. So what I'm going to do is I'm going to plug y equals x squared into this y right here. So we're going to say x squared equals 2x plus 3. And now we've gone from two variables to a single variable, and you know what to do from there. X squared minus 2x minus 3 equals 0. This factors into x minus 3, x plus 1 equals 0. So what this is telling us is that our x values are positive 3 and negative 1. What we have to do now is find the y values that correspond to it. Alright? So we can plug these back in. You plug 3 back into this one. For x, you see that y will give you 9. You plug negative 1 back in for x, and you'll see that you get a positive 1. So the solutions for this system of equations is 3, 9, and negative 1, 1. Remember, it's always going to be an ordered pair. It's not just a number. These numbers represent something on the graph. Alright, so let's look, we'll continue to look at the substitution method with a few more difficult examples. And that'll pretty much wrap up this one. So we want to solve the system x plus y squared equals 6 and x plus 2y equals 3. Recognize I can solve, with using the substitution method, I could solve for x or y. Right? But in this situation, I claim it's going to be easier to solve for x. Right? We'll solve this one for x. So solving here for x gives me x equals 3 minus 2y. And then we'll take this and plug it back into this equation here. So what that gives us is 3 minus 2y plus y squared equals 6. Now I'm going again from 2 variables to a single variable, and we know what to do from there. We can rearrange it. Y squared minus 2y, subtract your 6 over, gives you a minus 3 equals 0. And this factors very nicely into y minus 3, y plus 1. Recognize now these are y values. Over here, they're x values. So be careful when you set your ordered pair. We've got one value of 3 and one value of -1. We need to find our x values. We can take these y values and plug them into either one of these, whichever one's easiest. It doesn't really matter. Alright, so I'm going to plug it in here. So this gives me 6, subtracting 6 gives me a -3, so I should get -3. Plugging here gives me a -2, adding should give me a 5. So again, these are the solutions for this system of equations. Alright? Now if we were to put these on a graph, what we would find is that the graphs of these two equations intersect at these 2 points. And that's what is important to see here with these systems of equations. Alright? Let's do one more example with 2 variables, and then we'll do the next video with 3 variables. Solve the system. X squared plus y squared equals 25. X squared plus y equals 19. We can solve for either x or y. I claim if we solve for x squared here, we can plug that whole thing in up here. So this would give me x squared equals 19 minus y. So I can take this and plug it in for this x squared right here. So it's 19 minus y plus y squared equals 25. From that point forward, it's the same thing. Y squared minus y, looks like it's going to be a minus 6 equals 0. Factors again into y minus 3, y plus 2. So we have y values of a positive 3 and a negative 2. And again, we're solving to find our x's. So I'll plug this 3 in here, subtract. X squared equals 16. So x equals 4. Could be plus or minus 4. And then plugging in the -2 here, it's going to give me the square root of 21. Okay? And again, this is the solution to that system of equations. Alright, we'll cut this video off here. The next video will be showing you an example of solving systems of equations in 3 variables.